Okay, I'd like to go through these quiz answers, and I was lazy, so I just copied student papers to give the answers. And so the first one was this algebraic expression and simplify. So the key of this was to notice that the top was difference of squares. Right? Right? If you factor out the 9, you have x fourth minus 1, that's x squared minus 1, x squared plus 1. And then the denominator, when you combine the denominator and put the denominator over a common fraction, you get x squared plus 1 over x. The x goes up on the top. You have x squared plus 1 that cancels. And then you get the answer pops out directly. Now, if one person said this equal to axm plus bx to the n and tried to find a and b, and that's actually a correct method. The person made an algebra mistake. But you could just set this equal to ax to the n plus bx to the n and try to solve for a and b. That was an interesting method. Okay, question 2. Find all fifth roots of minus 2 plus 2 squared root of 3i. So first of all, you want to convert this to polar form. And a good thing would be to plot it. No, I didn't see anybody graph anything. But really, you should be if you graph things, that's really very helpful. And it gives you some idea of what's going on. So, for instance, if I do graph this, you can see minus 2 is over here. 1, 2. And 2 squared root of 3i is going to be up here. It's going to be bigger than 2, so it's going to be somewhere up here. Now, the square root of 3 is a tip-off that it's a special angle. And it's in the second quadrant. So even before calculating, I would guess that this is 2 pi over 3. Now, of course, you have to be careful because a lot of people use arctangent, and arctangent is ambiguous. You could have arctangent have the same for something in second quadrant and fourth quadrant. So you need to check the quadrant. So I do highly recommend that you plot things, and you can see what's actually going on. All right. So what you have to do in this case is find 1/5 root and then multiply by all the fifth roots of unity. Okay. And here's the formula here, and you can just sort of plug it in. N is 5, and this theta was 2 pi over 3. So you plug it in and simplify, you get the right answer. Okay. So let's go to the next one. Next one was supposed to show that something was pure real. And that, so here, I think that statement is up here a little bit. Let's equal a plus b. I suppose z plus z inverse is real, so that either z is real or z, absolute value of z equals 1. Okay, so z equals a plus bi. So here, I actually don't know a way to do this just with properties. There might be a way to do it, but this way does work. If you change the z to a plus bi and work it out what z and z inverse are, z is a plus bi, z inverse is this here. It's a minus bi over a squared plus b squared. All right. Then if you just put those two together, you get the real part and the imaginary part. And we want the imaginary part to be 0. The imaginary part factors into two factors. The way for a product to be 0 is either one of the factors is 0. So there are two cases. If b is 0, then this is 0. But b is 0 is the same thing as saying that z is real. Case 2, this quantity is 0, and this is the same thing as saying a squared plus b squared is 1. But a squared plus b squared is the square of the modulus. Okay, so that's how you get these two different cases. Okay. Kind of interesting that these two very different cases give the same result to make that real. It's kind of interesting. Okay. All right, last one. All right, so evaluate this expressed in polar form. Now, some people some people actually use the formulas for cosine and sine of pi over 12. Now, I don't know if you remember that. I certainly don't remember it. But I do want to let you know that you're not supposed to be consulting the internet for formulas like this. And you're not supposed to be consulting any other reference. So if you did, please stop doing it. If you remember this formula, then more power to you. But that's not something, but I kind of doubt that people actually did remember it. So please keep that in mind. Another thing I want to say is that some people gave decimals in their answers. No decimals. I don't want to see any decimals. This is a pure math course. It's not an engineering course. Well, it's not quite pure math, but the emphasis is on math and exact formulas. Please, no decimals in any of your answers. Okay. So, So let's go on with this. So this is a brute force method, and this person did something very interesting. He used angle addition formulas or angle subtraction formulas. He wrote this pi over 12 as the difference of 4 pi over 12 minus 3 pi over 12. But 4 pi over 12 is the same as 5 pi over 3. And 3 pi over 12 is the same thing as pi over 4. So in fact, you can get this expression, use it in terms of the cis of pi over 3 and cis of pi over 4. So cis of 3 pi over 4 we know. And then this one here, he did something similar. Right? So here we simplified down what the angles are. Right? And these individual ones are ones that I do know. Pi over 3, pi over 4, 3 pi over 4, and 2 pi over 3. Okay? So we're using the cis formula that the cis of the sum of angles is the product of the cis's. Okay? So you go ahead and have this, and then this one should be written as a product, I would think. I think it's probably going to do that farther down. But then you can work through. You get these numbers here, and you plug everything in, and it's long, and you finally come down to 0. Okay, but the idea was very nice to use these to express the pi over 12 in terms of angles that you know. Now I did give a hint, and with a hint it's an awful lot simpler. Okay, but you can actually factor out the pi over 12, and then when you factor out the pi over 12, you just subtract pi over 12 from all of the arguments. Okay, then you get cis of 0 plus cis of 8 pi over 12, 16 pi over 12, 0, 2 pi over 3, 4 pi over 3. Now if you plot this, again, if you plot it, you can see something very interesting. Okay, you have this here, and I'll use a different color for my cis. And pardon the rough drawing, but cis of 0 is out here, and cis of 2 pi over 3 is up here, and then cis of 4 pi over 3 is down here. All right. Now, so there's 1, there's 2, and there's 3. Okay. Now, if you add these three together, you can think of them as adding like vectors. Okay. If you add these three together, you start with this one, then you add this one, and then you add the other one, and you get down to 0. Okay. So you can see visually that the answer should be 0. The other way to see this is that those are the three third roots of unity. The 3/3 roots of unity. One of the extra problem in the homework was to show that the sums of the roots of unity is 0. Okay, so that's how you could do that one. Okay, just a brief review of the quiz.